Our first example, we're going to talk about, we're going to create a third degree Taylor polynomial for sine of x. And we're going to write it centered around x equals 0. Alright, so our a value is 0. So we know it's going to take this form. It's going to be f of a plus f prime of a times x minus a plus f double prime of a over 2 prime times x minus a squared plus f triple prime of a over 3 factorial times x minus a cubed. Alright, since we're doing it at a equals 0, it's going to look like this. Alright, so what we need here for the third degree Taylor polynomial, we need f of 0, f prime of 0, f double prime of 0, f triple prime of 0. Okay, so we need all the derivatives. Right? Any Taylor polynomial that's centered at x equals 0 is called a Maclaurin polynomial. So I need the first, second, third derivatives. Alright, so I have f of x, f prime of x, f double prime of x, f triple prime of x. And then I need to evaluate those at 0. So I want to lay this out beforehand. I have f of 0, f prime of 0, f double prime of 0, f triple prime of 0. Alright, I can then plug those into what I know the form of the third degree Taylor polynomial to be, the Maclaurin polynomial. I can plug those in, and then I clean those up, and then I can write it with the factorial. So notice here that I get f of 0 is 0, so this first term completely goes away. I don't have a constant term for sine of x. And the second derivative is 0, so the x squared term completely goes away. So for the sine of x, you can see that I only have the odd powers of x and their associated coefficients. So my final third degree Taylor polynomial, or third degree Maclaurin polynomial, is x minus x cubed over 3 factorial. And I can extend that pattern to find the 5th and the 7th degree Taylor polynomials, or Maclaurin polynomials in this case. All right, so there's some things we want to note about this. I have alternating signs because of the way the derivative of sine alternates in sine. Right, I have positive cosine, and then 2 derivatives later I have negative cosine, so I get 1 and negative 1. And the even powers all go away because the derivatives are equal to 0 there at x equals 0. So I have odd powers of x. I have the factorials. Right, another way, this 6 is 3 factorial. So x cubed over 3 factorial, 5 cubed over 5 factorial. I'm sorry, it's not 3. It's x cubed over 3 factorial, x to the 5th over 5 factorial, and then x to the 7th over 7 factorial. All right, alternating signs. So pause the video here for a second and put sine of x, put the third degree Taylor polynomial, the 5th degree Taylor polynomial, and the 7th degree Taylor polynomial into your calculator, and then take a look at them. Mine is already in, so pause the video here for a second and put those in and take a look at them, and I'm going to do likewise. All right, so when I look at this graph, there's sine of x, there's my third degree Taylor polynomial, there's my 5th degree Taylor polynomial coming in, and there's my 7th degree Taylor polynomial coming in. Alright, so you can see that the more terms I have, the better my approximation, the better model I have, which only makes sense. The higher degree my model is, the better it's going to fit that curve. And so I can see that the higher degree Taylor polynomials will fit sine of x farther and farther and farther away from where I centered my polynomial, right? I centered this approximation at x equals 0. And as I get farther and farther away, eventually I'm going to diverge from the sign of x, but the more terms I include, the better that model is.